I am Sophia, Assistant Professor, Department of Physics, Sakti College of Arts and Science for Women, Ottanjatram. Today topic wave function. A quantity with which quantum mechanics is concerned is the wave function of a body. Wave function psi is a quantity associated with a moving particle. It is a complex quantity. Psi of modulus squared is proportional to the probability of finding a particle at a particular point at a particular time. It is the probability density. Psi of modulus of squared equal to psi star psi. Psi is the probability amplitude. This is psi equal to a plus ib, then psi of star equal to a minus ib. Psi of modulus of squared equal to psi of star psi equal to a squared minus I squared b squared equal to a squared plus b squared. Normalization. Psi of modulus of squared is the probability density. The probability of finding the particle within an element of volume d tau. Psi of modulus of squared t tau, since the particle is definitely be somewhere, so integral of minus infinity to plus infinity psi of modulus of squared t tau equal to 1. That is normalization. A wave function that obeys this equation is said to be normalized. Properties of wave functions. First one must be finite everywhere. Psi is infinite for a particular point. It means an infinite large probability of finding the particles at that point. This would second one, it must be single valued. Psi has more than one value at any point. It means more than one value of probability of finding the particle at that point, which is obviously ridiculous. Third one, it must be continuous and have a continuous first derivative everywhere. Dou psi by dou x, dou psi by dou y, dou psi by dou z. Fourth one, it must be normalizable. Schrodinger's time independent wave function. One dimensional wave equation for the waves associated with a moving particle is psi x comma t equal to a e power I minus I divided h cross e t minus px, and psi of x comma t is equal to 0 equal to a e power 2 pi I divided lambda x, where psi is the wave amplitude for a given x, a is the maximum amplitude, lambda is the wavelength. Equation 1, dou squared psi by dou x squared equal to minus of 4 by square divided lambda squared psi. Equation 2, lambda equal to h by m naught b, 1 by lambda squared equal to m naught squared b squared divided h squared equal to 2 m naught 1 by 2 m naught b squared divided h squared, 1 by lambda squared equal to 2 m naught k by h squared, 1 by lambda squared equal to 2 m naught k by h squared, where k is the kinetic energy of the non-relativistic case, E is the total energy of the particle, and V is the potential energy of the particle. 1 by lambda squared equal to 2 m naught divided h squared E minus V. Equation 3. Equation 2, dou squared psi by dou x squared equal to minus 4 by square divided h squared 2 m naught E minus V the whole bracket psi. Dou squared psi by dou x squared plus 2 m naught divided h cross squared E minus V the whole bracket psi equal to 0. This is the time independent Schrodinger waves equation for a particle of mass m naught, total energy E, potential energy V, moving along the x-axis. If the particle is moving in three-dimensional space, then dou squared psi by dou x squared plus dou squared psi by dou y squared plus dou squared psi by dou z squared plus 2 m naught divided h cross squared e minus b the whole bracket psi is equal to 0. Del squared psi plus 2 m naught divided h cross squared e minus b the whole bracket psi is equal to 0. This is the time independent Schrodinger's wave equation for a particle in three-dimensional space. For a free particle V is equal to 0, the Schrodinger equation for a free particle del squared psi plus 2 m naught divided h cross squared E psi is equal to 0. Next, Schrodinger's time dependent wave function, wave equation. Wave equation for a free particle moving in plus x direction. Psi equal to ae power minus I divided h cross et minus px, equation 1, where E is the total energy and p is the momentum of the particle. Differentiating equation 1, dou squared psi by dou x squared equal to minus p squared divided h cross squared psi. P squared psi equal to minus h cross squared dou squared psi by dou x squared. Differentiating equation 1, dou psi by dou t equal to minus I e divided h cross squared psi. E psi equal to I h cross dou psi by dou t. For non-relativistic case, E equal to kinetic energy plus potential energy. E equal to p square divided 2m plus vxt. E psi equal to p square divided 2m psi plus v psi, using equation 2 and 3 in 4. I h cross dou psi by dou t equal to minus h cross square divided 2m dou square psi by dou x square plus v psi. This is the time dependent Schrodinger wave equation for a particle in one dimension. Thank you.